Welcome back to the Before AGI podcast. We're diving deep into diffusion models today, a fascinating area of AI that's been making waves. It's all about teaching AI to create. Honestly, it's kind of like magic.
It really is remarkable. We're talking about AI that can generate realistic images, compose music, even design potential new molecules for medicine. Yeah, it's a game changer.
So I've been looking through these sources, and the way they describe diffusion models is like watching an artist paint in reverse. Can you break that down for us?
Imagine watching a painting slowly dissolve until it's just a canvas of random brushstrokes. Now picture an AI learning how to reverse that process, step by step, to bring back the original image. That's essentially what a diffusion model does.
So it's not just copying an existing painting, it's learning the underlying process of creation, right?
Precisely. It's learning the essence of what makes a face, a landscape, a cat, whatever it's been trained on. And once it understands those fundamental patterns, it can use that knowledge to create something entirely new.
That's where the generative part comes in. These models are actually generating new data, not just mimicking what they've seen before.
Exactly. And this whole process happens in two key phases, forward diffusion and reverse diffusion. Think of forward diffusion like dropping ink into water. It spreads out, gets blurry, and eventually you can't tell where the original drop was.
Like watching a photo fade into static. And this process follows a specific pattern called a Markov chain, where each step only depends on the previous one. It's like a chain reaction, one thing leading to the next.
A great analogy. Now imagine trying to gather that ink back into its original drop. That's reverse diffusion. The AI uses a neural network, basically its brain, to slowly remove the noise it added, reconstructing the original image step by step.
Okay, so it learns to add noise, then learns to take it away, and in that process, it figures out how to create. But how does it know how much noise to add or remove at each step?
That's where things get really clever. The neural network doing the heavy lifting is often called a U-net. Imagine a U-shape. That's basically the structure of this network. It first squishes the image down, capturing its key features, then expands it back out, refining the details as it goes.
So it's like a detective zooming out to get the big picture of a crime scene, then focusing on the tiny details to piece together what happened.
Exactly. And to guide this whole process, the U-net uses something called time embeddings. Think of them like timestamps on each step of the noise adding and removing. It tells the U-net exactly where it is in the process.
Makes sense. So it's not just randomly adding or removing noise, it's following a specific timeline, almost like a recipe.
And what's even more interesting is that we can give the U-net additional instructions, like make it blue or add a hat. We do this using something called context embeddings, which are like creative prompts for the AI.
So we're not just letting the AI run wild, we can actually guide its creations, shaping the output.
Precisely. And this level of control is one of the reasons why diffusion models are so powerful. It's like having a conversation with the AI, steering it towards the results we want.
This is already blowing my mind, and we're just getting started.
Welcome back to our deep dive into diffusion models. Now you might be wondering where this all started, right? How did we get from painting analogies to AI that can practically read our minds and create?
Yeah, I'm curious about the history. Did someone just wake up one day and say, hey, let's teach AI to paint in reverse?
It wasn't quite that simple. The roots of diffusion models can be traced back to a 2015 research paper that introduced something called DDPMs, which stands for Denoising Diffusion Probabilistic Models. Quite a mouthful, right?
Definitely. So that's where the core concept of forward and reverse diffusion originated.
Exactly. Those researchers laid the foundation for everything we're discussing today. But back then, these models were slow, clunky, and not nearly as sophisticated as they are now. It took some time and a lot of brilliant minds to refine the process.
The sources mentioned algorithms like DDIM, which stands for Denoising Diffusion Implicit Models. What did they do to speed things up?
Remember how we talked about those timestamps, the time embeddings that guide the AI? Well, DDIM and similar algorithms figured out a way to skip some of those timestamps, essentially making the process more efficient without sacrificing quality.
So it's like fast forwarding through a movie, but still catching all the important scenes.
That's a great way to put it. And alongside these algorithmic improvements, researchers started experimenting with different neural network architectures, particularly the U-net we discussed earlier, which proved to be incredibly effective for image-related tasks.
So it's a combination of better algorithms and more powerful neural networks that really propelled diffusion models forward.
Precisely. And this led to an explosion of research and development, with new variations and improvements emerging rapidly.
One of those improvements mentioned in the sources is something called latent diffusion. Can you explain what that's all about?
Imagine you're building a house. You wouldn't start by stacking bricks directly, right? You'd first create a blueprint, a smaller representation that captures all the essential information.
So latent diffusion is like working with that blueprint instead of the full-blown image.
Exactly. It operates on compressed representations of the data, making the process even more efficient, especially when dealing with high-resolution images or complex datasets.
And that's how we got to models like Stable Diffusion, which have been making headlines for their ability to generate photorealistic images from text descriptions.
Stable Diffusion is a prime example of how far this technology has come. It's like having an AI artist who can take your words and turn them into stunning visuals.
That's incredible. It seems like every day there's a new breakthrough in AI, especially with these generative models.
It's a rapidly evolving field, and it's only going to get more exciting from here.
But there are also challenges, right? I mean, training these models requires massive amounts of data and computing power. That sounds pretty resource intensive.
That's true. The computational demands of diffusion models are still a significant hurdle. But despite these challenges, the potential benefits are so compelling that research and development continue at a breakneck pace.
It reminds me of the early days of aviation. The first airplanes were clunky and inefficient, but the dream of flight was so powerful that engineers kept pushing the boundaries.
Exactly. And just like aviation revolutionized transportation, diffusion models have the potential to revolutionize countless industries and aspects of our lives.
From personalized medical treatments to breathtaking works of art, these models are poised to reshape the world as we know it. It's both exciting and a little daunting to think about. Welcome back to the final part of our deep dive into diffusion models.
We've covered a lot of ground, from the basic mechanics to the historical evolution and the sheer potential of these models.
But before we wrap up, I want to step back and consider the bigger picture.
That's important. It's easy to get caught up in the technical details, but ultimately, diffusion models are about more than just algorithms and datasets.
They're changing the way we think about creativity, pushing the boundaries of what AI can do, honestly blurring the lines between human and machine-made.
It's like we're entering a new era of creation, where AI becomes a powerful tool for artists, musicians, scientists, and anyone who wants to bring their ideas to life.
And we're already seeing these models being used in so many different fields, from designing new drugs to composing music, generating art, and enhancing medical images.
And these are just the early applications. Think about the possibilities in education, where AI could create personalized learning experiences tailored to each student's needs.
Or imagine AI assistants that can help us write stories, compose music, or even design our dream homes.
The potential is truly mind-boggling. But like with any powerful technology, we need to approach these advancements with a sense of responsibility.
We need to be aware of the potential downsides, like the spread of misinformation or the creation of deepfakes.
That's why ongoing dialogue between researchers, policymakers, and the public is so crucial. We need to ensure these technologies are developed and used ethically for the benefit of society as a whole.
It's a shared responsibility that we all have a part in.
Absolutely. And by working together, we can harness the incredible power of diffusion models to create a more equitable, sustainable, and inspiring future.
So as we conclude this deep dive, I want to leave our listeners with a few key takeaways.
Please do.
Diffusion models are a truly transformative technology with the potential to reshape countless aspects of our lives.
They're already making waves in various fields, and we can expect even more groundbreaking applications to emerge in the coming years.
But it's important to remember that these advancements come with both opportunities and challenges.
We need to approach these technologies thoughtfully and ethically, ensuring that they're used responsibly and for the benefit of all.
And remember, the future of AI is not something that just happens to us. It's a future we create, collectively, through our choices and actions.
So stay curious, stay informed, and stay engaged in the conversation about the future of AI.
And for those of you who want to dive deeper into diffusion models and other AI topics, be sure to check out Ian Ochieng's YouTube channel, Ian Ochieng AI.
He has some fantastic tutorials and insights that can help you understand and even experiment with these powerful technologies.
And of course, don't forget to subscribe to the Before AGI podcast for more deep dives into the latest advancements in artificial intelligence.
We'll continue to explore the cutting edge of AI and break down complex topics in a way that's both informative and engaging.
Thanks for joining us on this journey into the world of diffusion models.
Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible with AI.
See you in the next deep dive.